Welcome to second part of lecture 15 on graph theory. Today we will learn two basic concepts, residual network and augmenting path in a network with respect to a given flow. These two concepts are important to find maximum flow in a network. So, I will start with residual network first. So, we talk about these two basic concepts. One is residual network and augmenting path. Okay. So, this residual network with respect to a given flow, so consider an arbitrary flow F in a network G. Then the residual network denoted by G F has the same vertices as the original network and one or two edges for each edge u v in the original network. So, I wrote this definition in the previous part also. Let me just repeat once more. If the flow amount in the edge u v is strictly less than the capacity of the edge u v, then there is a forward edge u v with capacity C f u v. This is the capacity of the edge forward edge u v in the residual network, and that capacity is C u v minus f u v. And the other condition is that if the flow u v is flow along the edge u v is strictly greater than 0, there is a backward edge with capacity C f. The backward edge is VU with capacity CFVU equal to F of UV. Well, as I said that of course, this is a very important concept. I will slowly explain the significance of this one also. Let me give an example to illustrate this one. So, I will consider this network. This is the source node and these are the other nodes. This is the sink node T. So, there is an edge from S to A which has capacity 3. There is an edge from S to B which has capacity 1. There is an edge from B to C which has capacity 5 and an edge from A to C with capacity 3, C to T with capacity 2, B to D with capacity 4, D to E with capacity 2, E to T with capacity 3. So, this is the network G and I said that this residual network concept, it is with respect to a flow. Now, let me just assign a flow here. So, I will send 0 an amount of flow along from S to A, 0 amount of flow from A to C and then from B S to B 1, the flow amount is 1 and B to C 1, C to T 1 and here B to D 0, D to E 0, E to T 0. Now, first we need to understand that this is a valid flow. This is a valid flow because you can see that everywhere. So, this is the notation, right, F flow capacity. So, everywhere you can see that the flow amount is less than or equal to the capacity, right. So, that capacity rule is satisfied. Now, look at the conservation rule. Now, you can see the amount of flow that is going to A is 0 and the amount of flow going out of A is 0. Similarly, if you look at the node C, the amount of flow that is going into C is 1 and the amount of flow that is going out of C is 1. Look at B, the amount of flow going into B is 1, the amount of flow that is going out of B is also 1. So, 1 plus 0 and similarly, the flow conservation rule is true for D and E because the amount of flow going into D is 0 and the amount of flow going out of D is also 0. Now, just for if I remove this 1 by say if I put 2, then the capacity rule is true that 2 is less than equal to 5, but the conservation rule is not true because here you can see that the amount of flow that is going into B is 1 and the amount of flow going out of B is 2. 2 plus 0. So, the flow conservation rule is not valid. So, that is why you can't put 2 here. I just wanted to clear such concepts. So, this is a valid flow. Okay. So, this residual network is with respect to arbitrary flow, that means valid flow of course. So, now I will draw the residual network of the network G with respect to this flow. Okay. So, it says that the residual network GF will have the same set of vertices. So, the vertices are again S A B C T D and E. Now, it says that one or two edges for each edge in the original network. Now, in the original network there is an edge from S to A. So, corresponds to this edge, there could be one edge in the residual network, or there could be two edges. Now, see in this case there will be only one edge, that is the forward edge. Since here if you can see that the flow is strictly less than the capacity. So, there is a forward edge u v with capacity 3 minus 0. So, there will be a forward edge from S to A with capacity 3, that is all, and there will not be any backward edge because the flow is 0, flow is not greater than 0. If the flow is greater than 0, strictly greater than 0, then only there will be a backward edge. Similarly, from A to C, this is very important. I will explain why this is required, why this residual network is required at some point of time. So, there will be a forward edge because the capacity is strictly less than, the flow is strictly less than the capacity. So, there will be a forward edge with capacity C minus F. Now, look at this edge S B. So, here you see that the first condition, this condition is not true, the flow is not strictly less than the capacity, it is less than or equal to. So, there will not be any forward edge here, and here you can see that the flow is strictly greater than 0. So, there will be only one, so there will be a backward edge. So, in the residual network, let me draw the backward edge using a different color. So, there will be a backward edge from S to B with capacity equal to the flow amount, that is 1. Okay. So, the capacity is 1. Now, look at this edge B C. So, here you can see that the capacity is the flow is strictly less than the capacity. So, there will be a forward edge with capacity 5 minus 1, that is 4, and also there will be a backward edge because the flow amount here is strictly greater than 0. So, there will be a backward edge. So, I am drawing all the backward edge with a different color. So, there will be backward edge of capacity 1. What about C T? So, there will be a forward edge of capacity 1, right, because the flow is strictly less than the capacity. So, there will be a forward edge of capacity 2 minus 1 and there will be a backward edge of capacity 1 because the flow amount is 1. Okay, now for BD it is clear there will be only one edge, that is the forward edge with capacity 4. For DE there will be only one forward edge, right, and that is of capacity 2, and for ET there will be only one edge, that is forward edge with capacity 3. And this is called the residual network of this network G with respect to the flow F. Okay, so I hope that you understood what is residual network. Next we talk about augmenting path. An augmenting path is simply a path from source S to sink T in the residual network. And this has a purpose whose purpose is to increase the flow. Okay. So, first I will explain how an augmenting path increases the flow amount. First let me find out augmenting path. So, here we can see that there is an augmenting path, that means we have to find a path from S to T. So, that path could be there are many maybe, but I can see that one path is S to A and then A to C and then C to T. So, the augmenting path here is P. Let me denote this augmenting path by P. So, P is S A C T, and now we talk about the capacity of this path. So, the capacity, the path capacity of a path is the minimum capacity of an edge along that path. So, what we want to mean by this one is that so here we took the path, we took the augmenting path, let me write here, we took the augmenting path P to be S A C T. So, the path capacity, which is denoted by delta P, is that you take the minimum of the capacity of S A, the capacity of A C. So, these are the edges on the path P and the capacity of C T. Okay. So, minimum of these 3 is equal to minimum of. So, the capacity of S A is 3, the capacity of A C is again 3 and the capacity of C T is equal to 1. So, this is the path capacity is 1. So, this is what the meaning of path capacity. So, what we do using this one is that by considering the augmenting path, P in that example of course, which is S A C T, we can increase the flow, we can increase the flow by delta P amount, that is the capacity of the flow, which is equal to 1 here unit, as the path capacity is okay. So, once you have an augmenting path, which is a path from the source to sink in the residual network, you compute the capacity of that path. If the capacity of the path is 1, you can increase the flow amount by 1 unit. So, if you recall in the first flow that we took, there the flow value was 1. I did not mention that, I will go back to that. So, now using this new this augmenting path, we can augment 1 unit of flow in that network. So, that means we can increase the flow by 1. So, the final flow in the network after augmenting this 1 unit of flow, it will become, the flow value will become 2. So, we will understand this part now. So, let me just mention here. So, this was our residual network. Here you can see the flow. What is the flow value here? What is the flow value that we, so we started with the flow, and the flow value, the value of the flow is 1. Now, using this augmenting path, we can make the flow of this, we can increase the flow by 1 unit, that means the flow will become 2. Okay. So, see, we considered this path. So, that means we will send 1 unit of flow along this path. So, the flow here will become, we replace this 0 by 1, we replace this 0 by 1 and we replace this 1 by 2. So, we are adding 1 unit of flow, or we are augmenting 1 unit of flow with respect to this augmenting path. So, let me just draw the new flow now. So, I can move to a next page. So, we increase the flow along the path P. The P means the one we considered in the example, increasing the flow along the path P with 1 unit yield the following flow. So, what flow we get now is that this one. So, this is the source and the other vertices are A, B, C, sink vertex T, D and E. So, now here the flow value along S A, it was 0 before, now it will become 1. So, 1 and capacity is 3. So, along A C the flow was 0 before, now it is 1 and the capacity is 3. Along C T before it was 1, now it will become 2 and the capacity is 2. So, S B it was 1 before, now it is 1 and B C it was 1 before, now also it is 1 and B D it is 0, 4, D E it is 0, 2 and E T it is 0, 3. Okay. So, we have increased the flow amount from 1 to 2. Now, the question is, can we increase it further? So, we will talk about the Ford-Fulkerson algorithm. It says that when you have a flow in a network, you compute the residual network, and if you can find an augmenting path in the residual network, you can increase the flow in that case. So, that means, so we have a new flow now, and again we will compute the residual network with respect to this new flow and see whether there exists a augmenting path in the new residual network. Okay. So, this is how the algorithm, I will talk about the algorithm of course, but this is sort of we are trying to explain the algorithm or sort of before stating the algorithm, I am illustrating the algorithm. So, let me just compute the residual network for this new flow with respect to this new flow, and then we will stop. So, here the residual network with respect to this new flow is this one, is the same set of vertices. So, the residual network, this is the network G and the flow is given, and this is my residual network. So, here as you remember, there will be a forward edge with capacity 2 and there will be a backward edge with capacity 1. So, AC there will be a forward edge of capacity 2 and there will be a backward edge of capacity 1. Here there will be no forward edge because the flow is equal to the capacity. So, there will be a backward edge of capacity 2 and this is 1. So, in this case for SB there will be a backward edge only of capacity 1 and for BC there will be a forward edge of capacity 4 and a backward edge of capacity 1 and for BD there will be a forward edge of capacity 4, no backward edge. For DE there will be a forward edge of capacity 2 and for ET there will be a forward edge with capacity 3. So, this is the residual network with respect to the new flow, and in the next lecture we learn how to find maximum flow in a given network using the idea of residual network and augmenting path. Thank you very much.